All right, welcome to lesson 4, bar graphs. So in this lesson, we'll just talk about bar graphs. So bar graph uses solid rectangles, squares, solid bar to represent numbers and to compare data. Bar graphs can be either horizontal or vertical. So in this first example, this is a vertical bar graph. Okay, and all these numbers, or all these values here, Boggle Burgers, Chucky Chicken, they all go on the bottom, okay? And all the numbers that correspond, so 33 would be there, 27 is there, 15, 18, and 7. So you just create your bar graph up to however high the numbers are. This is a horizontal bar graph. Same idea. The topics or the whatever we're talking about goes on this side, and the bars actually go horizontal, but they still correspond with values. So you could check, for example, this one is like 95, and this one's 70, so on and so forth. So for this first one, let's try and read some data. What day was the least number of books checked out? Well, the least number would be the shortest bar. So that is that day, so that's Monday. Or sorry, actually, forgot about Friday here. Friday's like 42 or something. So Friday would be the least number. The greatest number of books, well, that's Thursday. And what 2 days are about the same number of books? That's a good question. Maybe Wednesday and Monday. They're pretty similar. Wednesday and Monday. How many books were checked out on each of the days of the week? So Monday, I think we said like 42, 43, somewhere in there. Tuesday was 95. Wednesday, like 54. Thursday, that was 70. I'm doing this all backwards. Monday, that's this one. That's 50. Tuesday was 70. Wednesday, that was 54. Thursday was 95. And Friday was 43. But how many books were checked out altogether? You would add that up. So if you do that, 50 plus 70 plus 54 plus 95 plus 43, I get like 312 books checked out. Bar graphs can also include negative values. So these, you'll notice, are negative percentages, and these are positive percentages. So they can indicate increases and decreases. So this graph shows the percent increase or decrease of the mass of groups of laboratory mice in a nutrition experiment. So they fed them different foods, and then they weighed them after to see if they gained weight or lost weight. So for which cereal was the greatest change in mass observed? And it doesn't say positive or negative, so we can look at both cases. Well, this is negative 6%, but this is positive 8%. So space corn with a plus 8% change. The following table shows the mass of the average mouse in one of the cereal groups at the beginning of the experiment. Find the mass of each mouse at the end of the experiment. Round to the nearest gram. Well, there's no table here, so omit that. Example 3. So we're going to create a graph. We have a bunch of different kinds of shoes, and we have a different number sold. So on the left side of the graph, we're going to do the number sold, and on the bottom, we're doing the type of shoe. Now, each of these types of shoes are different, so we need to give them their own column. So this will be b-ball. This one here is going to be soccer. This one's tennis. This one is track spikes. This one is running. And this is baseball. And this is indoor court. Okay, so each one of them gets their own separate bar separated by a column. So we need to figure out the most. So the most here is 490. So let's think about our graph. Maybe that's 100, 200, 300, 400, and 500. So let's graph this. So basketball's 358. So we're going to go up to 350, just over 350. And then you can shade it in. Soccer's 216, so just over 200. Somewhere there. Tennis is 193. So just under 200. Track spike's 58, so just over 50. Running, is 490s, almost all the way up to 500. Baseball is 148, so just under 150. And indoor court's 87, so just kind of under 100 there. And we do need a title, so we're going to do amounts of shoes sold. Okay. So we have a title, we have the axis labels, and we have the data. So we're all done. Last one. Canadian census. So we have different cities, and we have their population in thousands. So this really means 1,987,000. But they don't want to put 1 million in there. It's too many numbers. So they'll just do it in thousands. So this is going to be the city on the bottom. And this is the population. And let's graph this. So Vancouver will be in this column. Calgary will be in that one. Victoria will be in that column. Edmonton, Saskatoon, Winnipeg, and lastly Regina. So the most population we have here is 1,987, so that's roughly 2,000. So let's figure out how we can fit 2,000 onto the left side of this graph. So if we go 100, 200, 300, 400, 500, 6, 7, 8, that's not going to be enough. So if we go up by 200, that should give us enough space. And that fits it all in. So Vancouver's almost up to 2,000. So we would create a bar almost up to 2,000. Calgary's 951. So it's just over there. Victoria's 312. So there's 300. Oops, a little bit more maybe. Edmonton 938, so it's very similar to Calgary. Saskatoon's 197, so just basically 200. Winnipeg 671, so we go to 600, almost 700. And lastly, Regina's almost 200. And we do need a title. So city populations.